Welcome to Ask and Learn.
In this problem, we have to determine the convergence or divergence of a series. And specifically, we have to determine the test to use. We're not told the test to use. So let's first start out with what we're given. We're given the series from n equals 1 to infinity of the square root of n to the fourth plus 1 all over n cubed plus n. Well, in this case, we can use the limit comparison test, and we can compare it with b sub n equals 1 over n. Now, why are we using 1 over n? Well, we know the convergence or divergence of the series of 1 over n. That's known. We can use that to compare the convergence or divergence of the series we're given. So we can take the limit as n approaches infinity of a sub n over b sub n. A sub n is what we're given, b sub n is what we're comparing it to. So we'll have the limit as n approaches infinity of the square root of n to the fourth plus 1 all over n cubed plus n. Then we'll divide that whole quantity by 1 over n. So we can do a little bit of simplification. Remember, dividing by a fraction is like multiplying by the reciprocal. So we'll get the limit as n approaches infinity of n times the square root of n to the fourth plus 1 all over n cubed plus n. And now we can solve that like a normal limit. What we'll do is we'll divide the numerator and the denominator by n cubed. When we do that, we'll get the limit as n approaches infinity of the square root of 1 plus 1 over n to the fourth divided by 1 plus 1 over n squared. And now we're in a position where we can plug in infinity. When we do that, we get the square root of 1 plus 0 all over 1 plus 0, and that is equivalent to 1. Now this is important because we got 1. 1 is not 0 and 1 is not infinity. This is a definitive number that tells us the convergence or divergence of our series. So what we can determine is that because the series from n equals 1 to infinity of 1 over n is a divergent series, and we got 1 as the answer to our limit, the series that we are given by the limit comparison test. So I hope that this problem helped you understand a little bit more about evaluating the convergence or divergence of a series and how we can use the limit comparison test to evaluate that.